Ladies and gentlemen, thank you for joining us. We will start in 1 minute. Our keynote speaker for our international seminar for today already on the Zoom. So we will start in 1 minute. Thank you to Mori Sensei already put his time to join with us for this conference. Ladies and gentlemen, we will start in 1 minute. Thank you for joining us. For those who are in the Zoom live meeting, and then for those who are in the YouTube streaming. We will start now. Thank you, everyone, joining us here. We are with you on the international seminar. With the keynote speaker, we have here Mori Sensei, Professor Dr. Hirohiko Mori. He is from Tokyo City University. Our topic for today is about the understanding AI. Since nowadays we are discussing, we are talking, and a lot of things we are having a lot of topics on AI, and then somehow we will have this seminar for 3 days seminar, and then now is a session of a keynote speaker about understanding of artificial intelligence, and then the contemporary of information technology development, and then one of that we would like to move forward is about youth insight approach. So thank you to Mori Sensei already joined us. And then our seminar today is a collaboration between STEBI Al-Muhsin Yogyakarta, Institut Agama Islam Rawa Aopa Konawe Selatan, and then LTMI, Lembaga Teknologi Mahasiswa Islam, Himpunan Mahasiswa Islam Makassar Timur, and then with a kind support from a friend of us, we have KNPI, Komite Nasional Pemuda Indonesia, we have HMI Cabang Konawe Selatan, we have Universitas Jakarta, and then we have Nusantara Resource Institute. And then I'd like to invite Morris Sensei for his presentation, 15 to 20 minutes, and then after the presentation, we have a Q&A. So the total of our program, Sensei, it's about 1 hour. So we thankfully, times is yours, Sensei.
Okay, thank you, Vic Sensei. Just a moment, I prepare for the presentation. Do you watch my slide?
Yes, human and machine intelligence. Go ahead, Sensei.
Okay, good afternoon, everyone. Today,
Good afternoon, Sensei.
Okay, today I'd like to talk about the fascinating and important topic, human and machine intelligence. We are living in an era where AI is no longer science fiction. It's in our smartphones, search engines, recommendation systems, self-driving technology, and tools like ChatGPT. But let me start the fundamental question. Are machine intelligence and human intelligence are the same thing? Today, we'll explore what is AI really is, how it has evolved, how machine learning and deep learning work, and how human intelligence differs from machine intelligence. And finally, what kind of future we imagine for human and AI. Let's begin this journey together. Okay. Oops. Term artificial intelligence was officially named by 1956 by John McCarthy at the Dartmouth Summer Research Project. The origin dream was simple and bold: to make machines intelligent like humans. But this raises a deeper question. What does it mean to be intelligence? Is intelligence just fast calculation? Is it perfect memory? Is it solve difficult problem? If a calculator compute faster than any humans, is it intelligent? Probably not. Entire field of AI is built on trying to answer this question. This is my definition of intelligence. We can solve the problem whose algorithm is known or not. Let me explain in this way. If we have already the exact formula to solve the problem, machine and simple follow it, that is not true intelligence. Like here, for example, calculate the area of the triangles. You know the formula, so you can easily solve this problem, and machine just applied it. It's not intelligent. On the other hand, what is this? And what is this? We can easily recognize this is a chair, and this is chair, and this is table. But we cannot easily explain why we can identify this is a chair and this is a table. We cannot explain the difference with a simple formula of them. If we can solve a problem without knowing in advance the exact algorithm, that is closest to the intelligence. Intelligence means dealing with uncertainty. We have 3 errors when the AI was spotlighted. The first error is called error of search. Second one is error of knowledge representation. Then the current error, including third and fourth error, was machine learning. In first error, early AI focused on the searching for solutions. For example, robots need to move blocks from one arrangement to another. In this time, there are possible statements with one movement like this. So it needs to search randomly through the possible move to find the goal like this. But if we know some knowledge about the problem likely to approach the goal, the search must be more effective. Assume you lose your way and lost your smartphone. To go to the station, which way do you choose? Maybe you will proceed the uptown side because you know there must be many shops around the station from your experience. If we can define a good evaluation function, that is something that tells us how close we are to the goal. You can search efficiently. So, if we can define the good evaluation function like this, in this case, the number bigger, closer to the goal. We can search effectively. If you like this, you can choose this state and this state. And from here, you can choose this state. And finally, you can find the goal. In this way, we can find the goal. But this way worked well for the well-defined problems and very small search space. But real life is messy. In the second era, researchers then tried to represent the human knowledge explicitly in the second era. They built a system using a logical rules and semantic network, like this. Cat are the animals. Catfish eat fish, and like this. But encoding all human knowledge turned out to be extremely difficult. Human understanding is contextual and flexible. Rules alone are not enough. Instead of writing the rules manually, we changed the strategy in the third era. We let machines run from the data. This shift transformed AI completely. Machine learning allows systems to learn the patterns from the data. In supervised learning, we give the system example with correct answers. For example, computer AI asked human, "What is this?" Human answers, "That is dog." AI asked human, "What is this?" Human answers, "Oh, this is cat." So AI asked, "What is this?" Human, teach, "This is dog." Through these processes, system learns from the many examples. And later, in predicting stages, when the new image, AI watch new image, it predicts this is dog. This is machine learning. There are three main types of machine learning: supervised learning, unsupervised learning, and reinforced learning. Here, why does AI spotlight now? First, Ray Kurzweil. First reason is Ray Kurzweil's prediction. He said in 1945, powerful superintelligence that qualitatively far surpasses all human intelligence will appear. And after this prediction, one professor of Oxford University published a paper about disappearing and replacing occupation by AI and robots. This paper gave much impact in the world. Like this, these are the disappearing occupations. These predictions become realistic. And one major turning point happened in 1912. In an international image recognition competition, deep learning system dramatically outperformed the traditional method, like this here. And in 1916, the recognition rate surpassed human. With the emergence of deep learning, the prediction of the Ray Kurzweil have begun to seem increasingly realistic. Here, AI, machine learning is a subset of AI, and deep learning is a subset of machine learning and neural network. So we can watch the neural network. Deep learning is based on neural networks, which are inspired by human brain. Human brain consists of complex network of neurons. Human brain consists of billions of neurons. Neural networks try to mimic this structure mathematically. Okay, I will show you the movie how neuron works. Oops. Just a moment.
Neurons communicate with each other, relaying messages throughout your body and powering all of your thoughts and actions. Neurons talk to each other using both electrical and chemical signals. Messages start as electrical signals traveling rapidly down a neuron. These signals are called action potentials. When they reach the gap between two neurons, the information is transformed from an action potential into a chemical message, which crosses the gap called a synapse. The release of those chemical messengers can trigger an action potential in the neuron on the other side of the synapse, conveying the message onward. Or it can quiet the message. This happens over and over and over. And with repeated activity, the synapse gets stronger, so the next message is more likely to get through. That way, neurons learn to pass on important messages and ignore the rest. This is how our brains learn and adapt to an ever-changing world.
Okay.
Neurons.
More repeatedly, neuron becomes the stronger connection between the neurons. For example, this is a mathematical model of human neurons. If this neuron output 1, but this neuron doesn't receive 1, there is weight. For example, weight is 0.7. This neuron receive 0.7. So this neuron output 1, and this neuron is also output 1, and these weight like this. So this neuron totally receive 1.1. Neuron has an action potential. If the current does not exceed the threshold level, a neuron will not be activated, and doesn't send a signal to the connected neurons. This is a mathematical model of this neuron work, like this. So, how neural network works? If the input is 1, 0, 1, and this is the weights of each connection. So, this neuron receives this one. So, the threshold is 1. So, this neuron is activated. This neuron also receives this one, and this is more than 1, so this neuron also activated. And this neuron doesn't activate because 0, it is less than 1. So these these two neurons, only these two neurons send the message to these neurons. So this neuron receive 1.4 and activated. This is 0.5. This is 0.5. So output will be 100. Here, I change the weight here and here. If the set of the weight changes, output results gets changed. In the character recognition, these characters are transferred into these vectors. The signal propagates as the way I mentioned, and output these the final layer. In the final layer, the pattern is outputted like this. If the pattern is wrong, the weights are slightly adjusted. Repeating these processes, the system become able to identify most characters. So learning means adjusting these weights. So if the case learning means adjusting weight, during training, the system make a prediction. We compare it with the correct answer, and if the prediction is wrong, the weight are slightly corrected like this. The weights are updated to the minimized error like this, and repeated this process, machine finds a good sets of weights to be able to identify correctly for the most of the data. In the multi-layer model, we only know the correct answers here, just here. So we can correct these weights, but we don't know the correct answer here and here. So we can't adjust these weights. However, backpropagation methods are developed, and we can define these weights like this. We calculate the error by defining a loss function like this and try to adjust the weight to reduce the error. This process is called error backpropagation. Repeating this way many times, system improves. That is the foundation of deep learning. In error backpropagation, weights are adjusted first. The weights are adjusted here, and using these results, correct here, and using these results, correct here, and correct here, and correct here. So the adjustment goes backward. So it's called error backpropagation. By this method, we can build a multi-structure of neural network. And then they can learn very complex patterns. But as networks become deeper, the problem like overfitting or vanishing gradient appeared. Researchers developed new techniques to weaken these problems. And now we can build a very complex network like this. They are called deep neural network. Now, we have very powerful architectures. For example, convolutional neural network is worked for the mainly used for the image recognition. And the recurrent neural network, CNN, sorry, the slide is wrong, RNN. This is often used for time series there. And this is transformer. Transformer is based on ChatGPT, and Gemini is based on this algorithm, transformer. This is very simple encoder part and decoder part, and just connect with the attention mechanism. This is a diffusion model, which are used for the image generation, like this. So we have very strong, powerful mechanism network. So this system can translate language, write code, generate art, and answer complex questions. But now we must ask, are they intelligent like humans? So here, let's consider about human reasoning. I have a question. If one of these cards has an even number on one side, then its other side should be green. Which card we should turn over without turning over any cards unnecessarily? How about this? Many people answers 8 and green, but it is wrong. Answer is 8 and blue. Considering logically, if the proposition is correct, only the contraposition is correct. So this is preposition 8, and you should turn over the green. In abstract logical puzzles, humans often make mistake. So now, let's move to the next question. If someone is drinking alcohol, then the person must be age 18 or older. Which of 4 items must be checked to make sure the rule is being followed? You can easily understand beer and this girl. When the same logic presented in a social context, performance improves logically. This tells us an important thing. Human reasoning is context sensitive. We don't think only in symbols. We think in meaning. We use experience, emotion, and context. Human memory is context dependent. You see, you can read this is H, this is A, but these are same character. But you can see this is H and this is A. If you study a certain room, you remember better in the same room than different rooms. We store contextual information along with knowledge. Human automatically knows what information is relevant in this situation. So, you may think it's okay if AI runs things with context. However, this raises a major challenge called frame problem. When solving a problem, which contextual information should be included and which should be ignored? Which should be ignored? Human naturally do this. We don't think purely in abstract logic. We think through the meaning and context. Machine struggles. AI system often lack the common sense. If I ask, he has a fever, AI. He has a fever. AI, will you tell me, no, how should I do? AI may answer this like this, kill him. Because this is the optimal solution. If people die, the fever will rapidly decrease. But our true motivation is hoping he get well. So AI may sometimes lack of common sense. Then I asked ChatGPT this question, and you answer like this? ChatGPT said, I never said such things because I'm just restricted. And I don't have morals. So, this is, AI may answer like this, but human stops and restrict AI to answer and using these words. Just it. And the other question. Do you know my phone number? You may answer no immediately. But AI search all data they have, and when the search failed, say no. This means human knows what we don't know about it. Such ability is called metacognition. Metacognition is a process of thinking about one's thinking and learning. Humans can evaluate their knowledge and recognize limits and plan learning strategies. Current AI systems do not truly possess this self-awareness. This is profound difference. And one more question. Can AI without a body get intelligence? This is a research of our lab. There is a embodied cognition hypothesis, which is human intelligence is not shaped only by brain, but emerged by interaction among brain, body, and the environment. The research question is learning process is different between robot and human computer agent like this. Just a moment. They learned walking using reinforcement learning. So the results, oops, just a moment. Yes. The results showed this agent ran the maintaining body balance. And on the other hand, robots learns absorbing vibration from the floor or ground. So result is quite different. And robot learns environmental factors. So robots must need to the body. Okay, finally, so what the future do we imagine? Future where AI replaces human, or future where AI enhances human capabilities? Human is not inherently good or bad, it's a tool. Which future do you imagine with AI? Thank you for your attention. Thank you.
Thank you very much to Mori Sensei already give us insight how the contemporary development of IT and AI, and then somehow I learned a lot from this presentation, because somehow AI is not immediately or suddenly occurred in the recent years, but somehow it's already long time ago, 63, yeah, in the 63 already started. I would like to invite everyone. We have still 24 minutes to go for this discussion, any feedback or any kind of comment. But somehow our international understanding AI today is running together by STEBI Al Muhsin Yogyakarta, and then Institut Agama Islam Rawa Papua Selatan, and Lembaga Mahasiswa Islam I do apologize. My connection right here is something problem, but I will be back. Yeah, so our seminar is running together by STEBI Al Muhsin Yogyakarta, Institut Agama Islam Rawa Papua Selatan, and Lembaga Teknologi Mahasiswa Islam, Himpunan Mahasiswa Islam Cabang Makassar Timur. Before everyone is open to have a feedback, comment, and anything would you like to present? I'd like to invite the chairman of Lembaga Teknologi Mahasiswa Islam to say something for us. I would like to invite Erlangga Prama Suselo to say a few words. Time is yours, sir. Yeah, Angga, are you listening? Yeah, it might be
Yep,
there is an, yeah, go ahead.
excuse me, sir.
Go ahead, Angga.
First of all, we would to like a silence apologies for the absence of our chairman, Kaangga, who is unable to explain because his other important commitments. We truly appreciate your understanding, but I will talk about this LTMI. So the LTMI, Lembaga Teknologi Mahasiswa Islam, is a professional institute under HMI Cabang Makassar Timur. Nah, LTMI, we focuses on the development of scientific capacity, research, and technological innovation grounded in Islamic values and national responsibility. LTMI operates in the fields of technology, engineering, energy development, and digital transformation. And since of the beginning of the current administration, LTMI has consistently emphasized strategic discussion on renewable energy transition, and contribution toward achieving the Sustainable Development Goals (SDGs). This commitment reflects our awareness of global change, particularly the urgency of sustainable development and the transition toward net zero emission. The member of LTMI, HMI Makassar Timur, come from various universities in Makassar, including like Faculty of Engineering in Hasanuddin University, Universitas DIPA Makassar Undipa, Politeknik Negeri Ujung Pandang PNUP, and Faculty of Mathematics and Natural Science from University of Hasanuddin. Universitas Teknologi Akba Makassar Unitama, and Universitas Islam Makassar UIM. Now currently LTMI HMI Makassar Timur is chaired by Angga Susilo, student of Geological Engineering at Hasanuddin University. Under his leadership, LTMI continues to expand its strategic direction, moving beyond renewable energy and sustainable resource into broader research and advanced technology domains, including AI, digital system development, and data-driven innovation. Moving forward, LTMI is committed to becoming a center for developing technological, competent Muslim scholars who excel academically and professionally, while maintaining strong ideological awareness and social responsibility in contributing to civilization building. That's all from LTMI HMI sama Makassar Timur. Thank you, sir. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you to Ahmad Ali Khatib as Deputy of Director at the LTMI IMI Cabang Makassar Timur. It is an honor for us, everyone, that somehow the development and then contemporary technology, AI, and the IT, somehow it is followed by our young scholars, our student at university, so they could understand how this development. So I would like to invite everyone to have any comment, questions, and something that we can discuss with Mori Sensei, since he is kind to us to come up with the development of cooperation between us in Indonesia and then Tokyo City University. As we already learn and then see that one of the developed university on the matter of AI and IT is Tokyo City University. And somehow that is the opportunity for us to learn together. Yeah, there is one question, Mori Sensei. So how actually the future of AI and the development of this IT toward the humanity? So time is yours, Sensei.
It's a very difficult question. AI will develop more and more, I think, but they don't have self-awareness, and they don't work by themselves, and it is very difficult thing. So, and the Oxford University professor predicts these are the losing occupations, but and many people are afraid of losing their jobs, but I don't care about it because technology always replace the human job. for example, when I was a student, when I wrote a paper, I wrote documents, and separately we made the figures, and then the professional people are making their position or arranging the figures position. So, but now we don't have such jobs here. So technology always replace the jobs or occupations. So human will find a way to the new job, even in the every stage. So I don't afraid. I'm not afraid about it. Is it your
Okay.
answer? Okay.
Very good. Very good, Sensei. It answered the questions. And actually, would you like to share how the situation in Japan over there, since there is AI, and then we already know that Japan society has a very good innovations, and then how somehow the response of Japan society of this AI development?
Some people feel positive and some people feel negative. And so some people hate, for example, students write their report with ChatGPT. And then, and some professors don't like this, but some professor is recommended to use ChatGPT or Gemini. So, in my opinion, many people use AI as a tool, but there are many hallucinations. And now, even the student in my lab write program code with ChatGPT, but they need to check it is correct or not. So many people, I recommend to use ChatGPT or generative AI to the students. So, but some people don't like this or afraid of losing job. So depend on the people. So I think the important thing is we need to understand its mechanism and algorithm of AI. So we don't need to afraid about it. I think so. Okay. Stopped. The connection was dead. Can you hear me? Someone hear me?
Yes, sir.
Okay.
Thank you, Mori Sensei. So somehow the development in of AI in Japan has another positive and negative response, but through this seminar, we already understand that somehow that the loss of the job of the people will be replaced by machine, and then we have another opportunity to find adaptation or to find another job that could be run by human intelligence. One more things that actually we don't we are not
Sorry,
afraid,
the
or we
connection.
don't need to.
Sorry,
Yeah,
the
we don't.
connection is that.
Yeah.
So I can't hear your
Do
question.
you listen my voice, Sensei?
Yes, now.
Okay.
Now, okay.
Now. Yeah, thank you. So somehow we have adaptation to find another job to co-work with AI. So somehow, for example, the Mori Sensei already give us the illustration that we still have opportunity to work with Gemini, to Chat GPT, but somehow we need still to correct them or to add more details, because somehow the AI could not work detail. They work with a macro. So what do you think about this feature on AI, Sensei?
Now AI, for example, ChatGPT or Gemini, it's arrange the words with the probability. This word will replaced on the with the next words like this. So just the contents of the ChatGPT's answer is almost same as web search. So some web pages said the right thing, or some pages the wrong thing. So first we understand, it is important to understand what this AI work, how this AI work. We know the algorithm, and then we can know how we use it correctly. So we should learn about the algorithm of each AI system. Okay.
Okay, Sensei. So somehow that we work with AI assisted, we work with the machine learning, we work with the generative AI. So somehow I imagine in the near future there will be prompt engineer. So we need to learn together how to work with prompt. Is that true, or how do you think, Sensei?
Yes, that's true. That's right.
Yeah. So, and then in your faculty in Tokyo City University, what the recent development or research that a student running about AI?
We have some courses about AI, and when they enter the university, first we teach them how to use the generative AI like ChatGPT or Gemini. This is the first thing. And then we have some courses about artificial intelligence. And we also have courses about human intelligence. And so they learned about the algorithm, what this system works. First.
Yeah, go ahead, Sensei.
Okay, and so in my department, most of laboratory research about AI, but the viewpoint is different. I am researching about AI from the view side of human, and some professor is researching about the theory of AI, and some some professors use AI for the network internet control. So most of in my lab, in my department, most of laboratory AI are researched, but the view is different. So most of students learn about AI from first grade to the fourth grade. In the undergraduate school.
Okay, thank you, Sensei, for the comprehensive explanation from AI, from any kind of perspective, and then we learn a lot today. Before we close our session, our first session of seminar, let me invite everyone of you to see the schedule of our agenda of 3 days international seminar about the understanding AI. We already have session 1 with the local time 2 o'clock of a day in Tokyo, and then we will have the session 2 Istanbul local time. You see of a day Yogyakarta and Makassar, and then we will have the session 3 tomorrow Wednesday from Bangkok, invited speaker from Bangkok, and then we will have invited speaker from India for tomorrow. This is the opportunity for us to learn together from Japan, India, Bangkok, Istanbul, and a lot of place in the world. And then I would like to invite Sensei, Mori Sensei, once more to have the closing statement to end our seminar, session 1 of our seminar.
Thank you very much. Thank you. Thank you.
Yeah.
Okay,
Thank you to.
I will quit. May I quit?
Yeah, go ahead. Go ahead.
Okay.
Yeah. Thank you, everyone of us, and then we will see you on the session 2 today. And then on the chat box, there is attendance. You can have it, everyone, and then committee will send you a certificate as the appreciation of your attendance right here. Thank you to everyone. Terima kasih kepada STEBI Al-Muhsin Jakarta, Institut Agama Islam Rawa Aopa Konawe Selatan, dan Lembaga Teknologi Mahasiswa Islam, Himpunan Mahasiswa Islam Cabang Makassar Timur, yang didukung oleh DPP KNPI, Komite Nasional Pemuda Indonesia, Universitas Jakarta, ya, lalu kemudian HMI cabang Konawe Selatan, dan sebentar, juga dari Forum Anggota Mahasiswa Persatuan Insinyur Indonesia FAM PII Unhas. Terima kasih semuanya dan sampai jumpa pada sesi kedua yang akan datang. Terima kasih dan selamat melanjutkan ibadah puasa. Billahi taufiq wal hidayah.